Good evening, everybody. Welcome to the Mexborough and Swinton Astronomical Society this evening. And good evening, Tim. We have been corresponding via email. So, Tim Cooper is a past president of the Astronomical Society of Southern Africa. He's also an honorary member of the Astronomical Society of Southern Africa, received their Long Service Award in 2008, and was the recipient of the Overbeek Medal in 2018, which is awarded for observational work published in recognized astronomical journals. Tim served as director of the ASSA, a comet, asteroid and meteor section for 2 decades, from 1993 to 2013. He's a member of the AAVSO with over 17,000 visual observations, and the International Meteor Organization, IMO, and the IAU named asteroid 22722 Timothy Cooper in recognition of his contributions to meteor observation, and in particular his investigation into bright fireballs and Bloodies. Now, a couple of extra little bits that he did send out when we first started corresponding, that Tim actually is a long time ago local of Dennerby, which you will all well know, apart from the ones that are joining us from Kent who'll have no idea where Dennerby is. But then perhaps one or two from Dennerby don't want to know where Dennerby is. So his family hails from Dennerby, and his father was born in Conisborough and attended college in Mexborough before he joined the army. He was born in Germany, and he emigrated to South Africa in 1971, and where his father was instrumental in nurturing his interest in astronomy. He's visited the area nearly every year, this is before COVID, researching my family history, which is nearing completion. Maybe in the not too distant future, I can visit you on your home turf. So, in the meantime, if the foreground sounds of interest and you would like to set up a talk on these or other aspects of astronomy in South Africa, you'll be pleased to assist, which brings us to where we are tonight. So please, all put your hands together and welcome Tim Cooper. Thank you, Tim.
Okay, are you seeing my screen?
We are.
Good show. So thank you very much for the introduction, and thank you very much for the opportunity to talk to you tonight. So I want to say a little bit more about astronomy in South Africa, what we do and what we can look at. And specifically, I'd like to say a little bit more about ASSA, which is the body to which I belong. That's the Astronomical Society of Southern Africa. And it's a very opportune time to do that, because this year is our 100th anniversary of the formation of ASSA. Okay, so what we'll do is just give a little bit of history, past activities of ASSA. We'll look at the current structure of the Astronomical Society of Southern Africa. Then I want to just touch on what we can see from all latitudes, specifically looking at some of the objects that you can't see from your northerly perspective. And then after that, I just want to touch on a little bit of serious amateur astronomy and tell you a little bit more about what some of our serious amateurs do down here as well. And then we'll just wrap that all up. So from a historical timeline, astronomy made a significant leap forward in South Africa from 1820 with the formation of the Cape Observatory. In 1879, Sir David Gill became HM astronomer at the Cape, and David Gill is one of the more influential people in South African astronomy. The observatory flourished under his leadership, and he in 1882 was the person who took the only the second photograph of the comet. That was the Great Comet of 1882. And he realized with that photograph that there were a lot of stars on there at the same time. And he realized that if he could measure those, he could make very accurate positional measurements of stars. And subsequently, he, together with people at the observatory, they measured the positions of over 500,000 southern stars, and that resulted in what is today known as the Cape Photographic Durchmusterung, the CPD catalogue, and it was also the forerunner of the star map that we now know as the Carte du Ciel. So David Gill also, he was very active in terms of measuring the positions of comets, together with another astronomer at the Cape, actually his assistant, which was William Finlay. They made a lot of positional measurements of comets, including the comet of 1882, and then subsequently in 1886, William Finlay discovered his own comet. So then in 1910, there was the appearance of Comet Halley, which was quite spectacular. It piqued the interest of people again in this part of the world. And as a result of that, shortly afterwards, we had the formation of the Cape Astronomical Association, and the first president of that Cape Astronomical Association was Sidney Howe, who took over as HM astronomer at the Cape from David Gill. A few years later, we then had in 1918 formation of the Johannesburg Astronomical Association, and its first president was Robert Innes. In 1922, those two, the Cape Astronomical Association and the Johannesburg Astronomical Association, merged together to form the Astronomical Society of South Africa. So that's a very auspicious date for us, 1922. Actually, in October, we celebrate our 100 years. And then in 1956, they changed the name to the Astronomical Society of Southern Africa, which then includes all the neighboring countries that are around us. And that includes places like Botswana, the old Rhodesia, which is now Zimbabwe, Mozambique, etc. So finally then, 2022 is ASSA's 100-year anniversary. So in the past 100 years, we have a fine legacy of observation by amateur astronomers within the ASSA organization. Right from the start of the AEVSO, the American Association of Variable Star Observers, we've had a very, very close association with them. So this slide shows you the number of variable star observations which have been input into the AEVSO database. And you can see that a vast proportion of those observations were made by 3 South African observers. First of all, by Harold Houghton in the early 1900s, then taking over from him, Reginald de Kock, who made 160,000 observations, visual observations, in the middle 1900s. And then he was followed by Dani Overbeek, who made 287,000 observations. And we recognize him, Dani Overbeek, today as a champion variable star observer with the most ever input into the AEVSO. So you can see here on the right-hand side, this is the total number of observations input into the database. Overbeek's are the open areas here, and all other observers are the shaded areas here. So you can see the contributions that these individuals have made into that. We then extended this legacy back some time. A team which was led by myself and Brian Fraser, together with the University of the Free State and the Boyden Observatory, we located another 70,000 observations which were made by another amateur astronomer, and this was Alex Roberts. He observed at the turn of the century, and we managed to extend the coverage of a lot of southern variable stars by around about 3 decades earlier than was already input into the AEVSO database. So if you look here, you can see as an example a light curve. If I can just put my pointer on. So here you have, as an example, a light curve of the long period variable R Centauri. It has a period of around about 500 days, and it has this rather curious double maximum. It has a bright maximum, then followed by a fainter maximum, and it does that over a period of around about 500 days. So that's the last 6 cycles of the star, going back around about 3,000 days. And at the bottom here, you have then the entire number of observations which were input into the BSO database, which gives you here, and you can see here that curiously the star seems to have had a narrowing of its amplitude and also a shortening of its period. And astronomers put this down to a helium flash in the atmosphere of that star. Now we sort of put a little bit of a spoke in the wheel when we added Robert's information onto that. And when we take Robert's observations and we input that into the database, we extend this period backwards by about 30 years. And you can see that in the times that he observed it, it had a similar short amplitude. So astronomers at the moment are trying to understand exactly why that should be the case. So that's the type of work that we've been doing in terms of variable star observation. It's formed a backbone of our organization for many years. Similarly, we have a very rich history in terms of comet discovery and observation. So we have 58 comets having been discovered from South Africa. The most are by William Reed and by Mike Bester. They have 6 discoveries each. Even Reginald de Kock, who you saw as a variable star on the previous slide, he discovered a comet himself serendipitously when he was observing the variable star R Lupi, and he realized there was something in the field that shouldn't be. So that was another comet discovery. Shows you how easy it is to discover a comet. Not. Right, so the most famous comet discoverer from these shores is a gentleman by the name of Jack Bennett. So this is Jack Bennett, who discovered comet 1969Y1. It became one of the great comets of the 20th century and was very bright in the early days of 1970. Jack Bennett was also famous as he was the first visual observer to discover a extragalactic supernova when he, during the comet search, discovered a supernova in M83, and that was supernova 1968L. So I've mentioned 1 or 2. There are obviously a lot more people that have made significant contributions to amateur astronomy in this country, but I mentioned people like Overbeek and Jack Bennett because they are the people that mentored me, and as a result of that, so I believe it's my responsibility to continue that legacy and mentor other young observers today. So 100 years later, this is what ASSA looks like. So ASSA, Astronomical Society of Southern Africa, it's a body consisting of both professional and amateur astronomers. We are divided up into an umbrella body, which then runs the autonomous centers. We have a number of sections. We issue a number of publications, and then we have some additional events like our biennial symposium. So if we look at our centers, this is a map of South Africa with our different provinces. Our most populous region, which is the area where I reside, is here in the region of Johannesburg. So we have a center in Johannesburg, we have a center in Pretoria, and then the other major urban centers around Cape Town. We have the Cape Center on the East Coast, we have the Durban Center, 2 centers at the South Coast here, Homunculus Center and Garden Center, and then in the middle of the country we have the Bloemfontein Center. All members of those centers then are ASSA members automatically. As a result of the fees that they pay, they get the annual Sky Guide, which is a publication which has now been issued for the last 76 years. It replaces our annual handbook, and it's a very, very good publication which gives very, very detailed information about what is visible each night. Then we also issue the peer-reviewed monthly notes of the Astronomical Society of Southern Africa, MSAS. This contains articles of scientific value from both amateur and professional astronomers, and that's available for free download on our site. You can just go to the download site and have a look at exactly what you're doing. So all of the observations that I make, whether it's comets or meteors or variable stars, I publish in the monthly notes of the Astronomical Society. Then we have a sort of a glossy brochure called Nightfall. This is edited by a gentleman called Doug Bullis, who I believe, if I read your site correctly, is due to give you a talk next month. So I'll not steal his thunder. Okay, so we have various sections. First of all, dedicated to observing. We have a deep sky section. We have a shallow sky section, which is the opposite of deep sky. So shallow sky section is anything to do with the solar system. That includes observation of the sun, moon, planets, comets, asteroids, and meteors. Then we have dedicated section towards double star and variable star observing. Variable star is the only section which has been around since day one, and it still goes from strength to strength. We have a section covering astrophotography, spectroscopy, and photometry. And then we have numerous interest sections which are not involved in observing directly, including then dark sky, historical, and an instrumentation section. So in terms of instrumentation, we, because the South African rand, our currency is not very strong, it costs a fortune to buy decent equipment nowadays. So a lot of people prefer to make their own. So we've had a amateur telescope making classes for the last 30 years, where people get together, they grind their own mirrors, make their own telescopes. And this is our leader of that project, which is our current president, Chris Stewart, and there he is holding the mirror blank for a 14-inch telescope. So we have people of all disciplines, all ages. The youngest one to grind the mirror was 9 years old, and the oldest one was 90. We have some very sophisticated members too. So this is Jan Swanepoel. He creates some rather large mirrors with a mirror grinding machine, which he made from an old washing machine. And so generally what they have is in these classes, they learn how to make Newtonian and Dobsonian telescopes. And most of the telescopes that they make are that ilk. And then we have a few of our genius members. They make some more intricate telescopes, like for example here, this is a good Schiefspiegler. Right, so have telescope, will travel. So what can we observe? First of all, this is once again a map of the country. It's a light pollution map, so you can see here that South Africa is quite a large country. We have some very, very open spaces here with some very dark skies. And then you can see here in the urban areas, there's a lot more light pollution. So that's how we are. And if we then superimpose on top of that again our centers, which is where most of the amateur astronomers are based, it doesn't look quite such a pretty picture. So all of our amateur astronomers are based in these areas where there is a lot of light pollution. And yet we still seem to manage to do some very fine work. So that's the superimposition of the centers on top of that light pollution map. If I take those away and I show you my position, so I am here where the red target is, just on the outskirts of the most populous area of the country in Johannesburg. If we hone in on that a little bit greater detail, that once again is my location there. You can see here that Johannesburg, which is a city of around about 6 million people, is just down to my southwest, and I've got another city just north of me, which is Pretoria. That's around about another 2.5 million people. So I'm surrounded by something like around about 8 to 9 million people. And you can see that in my southwest direction, the skies are not too good. But looking towards the east and the northeast, my skies are actually not too bad, and I still manage to do some pretty good work. Just as a comparison, that's your situation there, I think. So you probably have it slightly worse than I do. So you have Rotherham to your south, and you have Doncaster to your east. And if you look at the light pollution there, you have some of these areas where you have the purple, which I don't have. And most of the area is surrounding you have this yellow and orange. So it's pretty much similar skies to what I have. Okay, so from your location, 53.5 degrees north, looking south, what can you see and what can you not see? So this is a map of the heavens stretched out there, which is from 60 degrees north down to the South Pole, 90 degrees south. So if I put on the red line, so everything below that red line you don't see from your location. Everything below that orange line there is culminates at around about 15 degrees above your horizon. So you've got the galactic plane here. The center of our Milky Way galaxy is that yellow target there. So the center of our Milky Way galaxy, which is where many of the showpieces are for us, just about rises above your horizon in MSAS and Swinton. So if we look at that in a little bit more detail, looking south, once again, the red line is the area above which nothing for you rises. So I guess you don't get to see the tail of Scorpius. The center of our galaxy just about rises above the horizon. But this area here, where there is a lot of interesting objects for us, which is the area around the Southern Cross and Centaurus, remains very far south, and you don't get to see that at all. So we'll have a look at a few objects in that area tonight. So that's pretty much what the Milky Way looks like from us. I'm not ordinarily a fan of these photographs that are taken, which show the Milky Way in this contorted fashion. But it does at least give us some idea, a short range, what we do get to see that you don't. So the center of the galaxy is over here. You can see the central bulge of the Milky Way in this area here. And here is the one arm moving out in towards the Southern Cross, which is here, Centaurus and Carina. So I want to concentrate a little bit more on this area here, inside this box, which is the area around the Southern Cross. It's a useful point to basically jump off from. Just by the way, the dome at the bottom there in this picture is the dome of the South African Large Telescope, which is the largest telescope in the Southern Hemisphere. So that's the dome, and then immediately to its right, you can see the large Magellanic Cloud, and the small Magellanic Cloud is hidden just behind the dome. Bad planning on the point of the person who took the photograph. Right, back to this area here, then around the Southern Cross. And this is the area of what we call the Big Five of the African sky. That Big Five then is the Milky Way, the Southern Pleiades, the Coalsack Nebula, the Omega Nebula, and the Ita Karina Nebula. So this Big Five, it actually gets its name from the Big Five of the African bush, which were traditionally the five animals which were most difficult to hunt on foot. That being then lion, leopard, the rhino, black rhino, what have I missed? Buffalo, if I say elephant. So that's the five, and they are known as the Big Five. Fortunately, nowadays they are more popular in tour guides than they are with hunters. So we have a 5 in our sky, big 5 in our sky. It's those 5 objects, and I'll take a bit more of a look at those now. So that is the area that we're talking about. So here we have the Southern Cross. If you haven't seen it before, this is the Southern Cross. These are the 2 pointers to the Southern Cross, Alpha Centauri and Beta Centauri. And we'll look at these objects in a little bit more detail. You can see it's a very rich area, something that gives us hours of pleasure just basically looking at these objects. So this is a map of the area. There again is the Southern Cross. You can see here at the same time as the Southern Cross, we have 2 other crosses. So there are 4 stars here in the form of a diamond. We call this the Diamond Cross. And then there's another cross here, which is called the False Cross. A lot of people from the Northern Hemisphere coming to the Southern Hemisphere, they see this cross and they think that's the Southern Cross. It's larger than the Southern Cross, but it's not. It's the False Cross. The Southern Cross is easy to find because it's the only one that has 2 bright stars pointing to it. And so we call these the pointers, Alpha Centauri and Beta Centauri. They point to the Southern Cross. Right, so the first one of the big 5 is the coal sack. And basically, here is Alpha Crucis, brightest star in the Southern Cross. Here is Beta Crucis, and then you have this large, dark cloud of material, which is very, very prominent under a dark sky, and it really lives up to its name, which is then the coal sack. Moving then towards the west, we have the Southern Pleiades. That's there. And that's the Southern Pleiades. This is a picture which has been taken by one of our amateur astronomers, Carol Berta. She's taken a few pictures on the SLU telescope and stitched them together to give this image then of the Southern Pleiades. Around about 20 stars in that cluster, ranging from magnitudes 2 to 5. And then at the bottom there you can see there's a very faint cluster, which is Maloti 101. And if we compare then the Southern Pleiades with the Northern Pleiades, we get that situation there. So I'll give you that Messier 42, the Northern Pleiades, is by far the more spectacular object. So 1-0 to the Northern Hemisphere. Right, next item, next object is the Ita Karina Nebula. So this is a picture taken by another of our amateur astronomers, Lafra Smith. And so this is the Ita Karina Nebula. It's a vast cloud of H2 region where new stars are being born. And you can see also lots and lots of dust clouds superimposed on the background radiation. And then you have here the actual star, Eta Carina itself, is this bright star, which you can see just behind there. And adjacent to Eta Carina, you then have the Keyhole Nebula, which is this dark area, which looks very much like the shape of the keyhole. So that is the Eta Carina Nebula. The star itself, Eta Carina, is very, very interesting to watch. It is a star which is very unstable. It is emitting matter at a considerable rate. And that matter forms around the star in the form of a shell, which is takes the form of 2 lobes. And we call this the Homunculus Nebula. So Eta Carina, the star itself, is in the center there. And then the material which it is emitting, you can see as these 2 bright lobes. Now, these 2 bright lobes are fairly easy to see in a relatively small telescope. So I was having a look at this a couple of nights ago. One of our amateur astronomers who observes with me, she was observing this object, and she said she felt that one of these lobes, this lobe here, seemed to be a little bit fainter than usual. And so I took a look at it and I said, yes, it does seem to be a bit fainter than usual. But then when I measured the light from the star, it appears that it is not because the nebula has faded, but because Ita Karina itself has become a lot brighter. So Ita Karina is a fascinating star. If you look at a light curve of the star, you can see back in the 1800s, it had an outburst, and for a brief period, it reached magnitude -1. It was the second brightest star in the sky after Sirius. And then in the years after that, 30 or 40 years after that, it faded down to around about magnitude 7.5. It stayed around that area for quite some time. And then in the middle of the 1900s, started to brighten. When I started to look at this object when I was much younger, around about 1980, it was around about magnitude 6. It continues to brighten, and last night when I observed it, it was magnitude 3.9. So this is a star which continues to brighten. We believe it may be a star which is nearing the end of its life and may soon become a supernova. And if that is the case, then it will certainly outshine the magnitude -1 that it did in the year 1845. Right, moving on to Omega Centauri. So Omega Centauri, if you take the two pointers, Alpha and Beta Centauri, you then take a line through Gamma Centauri, you extend that further, you come to the very bright globular cluster Omega Centauri. It's magnitude 3.5. It's fairly easily visible to the naked eye as a large fuzzy, almost like a star. And that is an image taken of Omega Centauri by another one of our amateurs, Angus Burns. I've never counted the stars in that cluster, but I'm told that it's probably in the region of around about 1 billion stars. Okay, so that's the brightest globular cluster in the sky, and so I have to compare that with your brightest, which I believe is M13, Messier 13, which is also known as the Great Cluster. And so M13 on the left-hand side, Omega Centauri on the right-hand side. So I think that makes it an equalizer for the Southern Hemisphere 1, Northern Hemisphere 1. Apart from those objects in the Big Five, there are a few other objects of interest in this area. So if you look at the Southern Cross again, Alpha Centauri, Beta Centauri is here. Next to Beta Centauri is a cluster which we call the Jawbox. It was discovered in the 1750s by the Abbé de la Caille when he visited the Cape. And it was then named the Jawbox by John Herschel. So John Herschel, when he was at the Cape during around about the period 1834 to 1838. So this is the Jawbox cluster. It's rather a nice object. It looks a little bit like a capital A. It gets its name, the Jawbox, from the different colors that you see with a large telescope. But I think it looks a little bit more like a Christmas tree with bright and decorative ornaments. Another object in this area then is what we call the dark Doodad. So if you take a line through the Southern Cross, and just as an aside, I don't know if you know how to find south. If you take the Southern Cross and you extend a line through the Southern Cross in that direction, you take a line perpendicular to the two pointers in that direction, and where those two lines cross, that is pretty much where our South Pole is. We don't have a bright star there like you do, so you can't line your telescope up on that point, but it is quite useful if you're navigating to find where south is. Right, so once again, if we take a line through these two stars towards this direction, we come to the dark Doodad. It's a dark nebula. This is a map. It's in the constellation of Musca the Fly. This is a map prepared by another of our amateur astronomers, Magda Streicher, who we'll hear a little bit more about later on. So that is her map of Musca. This is the dark Doodad, and that's the appearance of dark Doodad as it would appear in binoculars. A little bit further to the west, then we come to another object, which is called Cooper's Lane. And yes, it is named after me. So I just happened to be scanning around the area some years ago, and with binoculars, and I came around this lane. It just looked like a dark stripe against the background stars. It was just jet black. There were no stars visible in the lane, and I reported it. It turned out that it had never been documented before, or never been observed as such or catalogued before, and so now it's known as Cooper's Lane. So Cooper's Lane is this little area here. So just in summary again, this is the area around the Southern Cross. The Southern Cross, then you recognize now the two pointers to the Southern Cross. The big five, then we have the coal sack, so that is the coal sack. The Southern Pleiades is here. This is the Eta Carinae Nebula. Then we have Omega Centauri, the globular cluster is over here. And then the additional objects, this is the Jawbox Cluster, the dark Doodad, and Cooper's Lane. There is another one of the big five in this area, which then is the Milky Way. But the Milky Way is brighter elsewhere than it is in this region around the Southern Cross. And of course, we have the center of our galaxy pretty much overhead during our winter evenings, and that's when you get to see the Milky Way in all its glory. So this is a picture of the Milky Way centered round about the center of our galaxy, and you can see then the central hub around here, and then the two spiral arms radiating out in both directions. Now, the most recognizable constellation in this area is Scorpius, which is over here. And if we just add that, then you can see it. Scorpius is one of the few constellations that you can really make out a scorpion from this. So there you can see the head and the pincers. This is Antares, the bright red giant, which is the heart of the scorpion, moving around through the tail and then into the sting. So that is Scorpius, the scorpion. And then down towards this area here, we have Sagittarius. Sagittarius then is a mythical character, half beast, half man, with a bow and arrow. So he's the archer. And I challenge anybody to try and make an archer out of this agglomeration of stars here. So we don't even go to try to do that. We recognize Sagittarius then as a teapot. So this is the teapot, the brightest stars of Sagittarius. There's the handle, there's the body of the pot, there's the lid, there's the spout. And then the center of our galaxy is just off the spout in that position there. Also, you can see here some dark nebulae. This is the Pipe Nebula. And you'll also see in that picture some areas here of emission nebulae. We'll take a little bit more detailed look at those in just a moment. So those are the most recognizable constellations towards the center of our galaxy. Come back to Scorpius. There is Scorpius again. So here you have again the head of the scorpion. This is Delta Scorpii. Comes through. Antares is there. This is the area which we call row of Leuci. Then it comes around to the table of Scorpius, and then down through into the sting of Scorpius in these rich star clouds in the Milky Way. So this is, as I grew up, pretty much how I recognize the scorpion. But a few years ago, that appearance changed a little bit. And one of those stars started to brighten suddenly. So here is the scorpion again, now on its side. And there is Delta Scorpii. And you can see if you compare these two images, Delta Scorpii here is brighter. So all of a sudden, for no apparent reason, Delta Scorpii started to get brighter. And this is a light curve of what happened. So around about year 2000, you can see it started to brighten from around about magnitude 2.5, which is where it used to pretty much sit constantly. It brightened up to magnitude 1.8, faded again down to 2.2, and then it brightened up again to magnitude 1.9, and it's pretty much stayed there ever since. So this is a light curve based on the AVSO observations. There are around about 7,000 observations in that light curve, and 607 of those 7,000 were made by one person. That's Brian Fraser, who is a member of our association. That, by the way, then is Delta Scorpio has now been classified as a Gamma Cassiopeia type variable star, which shows these slow variations over a period of sometimes decades. Mentioned these bright emission nebulae. So these are 4 of our showpiece objects. They're pictures taken by 2 of our amateurs, Lafra Smith and Angus Burns. So Messier 8, the Lagoon Nebula, is this one here. Then we have 16, which is the Eagle Nebula, which you'll know from the Hubble pictures of the pillars of creation in this area here of the Eagle. Messier 17 is the Omega Nebula, also called the Swan Nebula. And then Messier 20 is the Trifid Nebula. So you can see here, this is the emission part of the nebula, and this is the reflection part of the nebula, which is reflecting starlight from stars nearby. So these are all showpiece objects. Whenever I go out and I give viewing evenings to the public, I always include these 4 objects. Technically, they are probably just about visible to you. They range in declination between 13 and 25 south. So you probably would just about see these objects peeping above the horizon from where you are. If we go even further south, we come then to the 2 Magellanic Clouds, the Large Magellanic Cloud and the Small Magellanic Clouds. These are irregular galaxies, which are satellite galaxies of our own. They are around about 190 and 200,000 light years away. And you can see that these are quite spectacular from a dark sky sight. This is the cloud itself, and you can see a lot of other clusters and nebulae in the vicinity of these objects, and you can spend hours and hours looking at just these 2 objects. So this is the Large Magellanic Cloud. In the vicinity of the Large Magellanic Cloud, you also have the Tarantula Nebula, which is NGC 2070. So that's that object there. If we look at that in a little bit more detail, there we have it. So this is the Tarantula Nebula. It's a vast area of new star formation. And in 1987, we were treated to a supernova in this nebula. That was Supernova 1987A, which very briefly reached magnitude 2.5. So it was quite bright and created some excitement for us. So that is the Tarantula Nebula in the Large Magellanic Cloud. This is the smaller Magellanic Cloud. At the top here you have the bright globular cluster 47 Tucanae, also called NGC 104. And then you can also see there's another globular cluster, NGC 362, which is on the left-hand side here then of the Magellanic Cloud. So these Magellanic Clouds, the large and small Magellanic Clouds, they are very far south. They are at declinations -70 and -73 degrees. They are best seen during our summer months, so they're very, very high at the moment, about as high as they get. So we get to see these objects in all their glory between December and February. And then during the winter, they are, well, they never really set, but they are very low above our horizon too. So for those who are interested in ASSA in looking at deep sky objects, we also have what we call the ASSA Top 100. So the ASSA Top 100 is the 100 most spectacular deep sky objects which are visible in the southern hemisphere. They're all south of the equator. The most northerly object is Messier 77, which is a galaxy in Cetus, and that is just south of the celestial equator. So these are all objects which are very good for us to observe. We offer a certificate to members who've observed and documented the observations of all 100 objects. Right, so that's from a stargazing point of view. I just want to touch on a little bit more about some serious amateur astronomy. First up is a very dear friend of mine, Magda Streicher. So Magda has been observing the heavens for the past 25 years, very diligently. She's a deep sky observer. She has documented pretty much all the deep sky observation objects that are to be observed in all 88 constellations, and she has put all of those together into a book which is called Astronomy Delights, and that book is available as a free download PDF on the ASSA website. So Magda has spent hours and hours at the telescope. She has documented everything that she's observed. She has sketched most objects that she's observed as well. Another thing that Magda has done during her observations of all these deep sky objects, she's made a number of discoveries of what we call asterisms. So these are groups of stars which are not related to each other in space, but just a line of sight, and they form these nice little patterns. She has discovered over 100. 106 of them have been credited to her and given Streicher numbers. So this is just a selection of those objects, and she's put all of those together into another book which she called Asterisms, the Hiding Jewels. So these are just a few of the asterisms that she has discovered. There are some nice objects here, and this is one of my favorites here. This one is called the praying mantis. So you can make out a praying mantis here with the two large eyes staring back at you from space. Also now, with the advent of very sophisticated measurement of star positions with the Gaia satellite, some of the asterisms that Magda has discovered have now been reclassified as open clusters because the stars in these objects, they have common proper motion and are in the same region of space. So what was previously classified as asterism Streicher 52 is now also known as open cluster Cohen Gaia 27, and at the same time Streicher 54 is now called Cohen Gaia 28. So these are actually open clusters in space associated with each other. Berta Monard is a gentleman who decided at the turn of the millennium that he wanted to search for extragalactic supernovae. And so he and his wife came round to me one day and asked could he look through my 16-inch Dobsonian telescope, which he did. He was captivated. He decided then to buy his own, which is the telescope that you can see on the left-hand side. He spent thousands of hours searching for its first supernova, and finally he bagged it in 2001. But not wanting to spend thousands and thousands of hours looking for the next one, he decided to get himself a CCD camera and a Schmidt-Cassegrain telescope, and since that time he has discovered 150 extragalactic supernovae. So just as an example, this is one of the objects which Berto has discovered. This was the supernova 2007Y in NGC 1187. So these are actually images taken by Berto. This was the discovery image. You then have to take a confirmation image, which is that one there. You can see that Berto was able to follow that object around about from February up until June of 2007, at which time it became too faint for him. fear not, it was also observed by professional astronomers. And so this was a picture taken near the end of 2007. And you can see Bertot's supernova here, this image taken with the Very Large Telescope. Clyde Foster is a gentleman who is very involved in planetary imaging. He is located fairly close to me in one of the most light polluted areas of the country. But he's got around that by taking images, concentrating on taking images of Mars, Jupiter, and Saturn. So that's his setup there. So Clyde has been the first amateur to detect a number of dust storms on Mars. So this was the progression of the dust storm that took place in June 2018. You can see here as it gathers momentum, and then 3 weeks later you can see that this dust storm has almost completely obliterated the one hemisphere of Mars. So Syrtis Major is around about here. This is the Hellas Basin here, and then you can see this dust is now even encroaching across the south pole of Mars as well. So this was the dust storm in 2018. And breaking news is that Clyde would have been with us tonight, but he's gone to bed early. He actually this morning discovered a new dust storm on Mars, just breaking out, the first of the season. And that's quite a feat because Mars has literally just popped its head up in the eastern skies in the early mornings, and its disk currently only extends around about 4.3 arc seconds. So even with that, under those poor conditions with such a small image, Clyde has just discovered or just detected another dust storm on Mars this morning. So we're eagerly waiting to hear from him tomorrow as to see what's happening. He does a lot of work with Saturn. So this is an image of Saturn by Clyde. And he's had papers published, including with geophysical research letters on the interactions of the winds on Saturn around the polar hexagon, which is this region here at the top of Saturn. His best work has been reserved on Jupiter. So Clyde does a lot of work with professional astronomers and is very involved with the NASA Juno probe team. Imaging, they use his images of Jupiter to plan what they do around that planet. And he was very fortunate on the 31st of May 2020 to image a new convective storm busy developing in the high atmosphere of Jupiter. So this was his discovery image of the spot there. You can just see that bright spot just down to the lower right of the Great Red Spot. And fortuitously, 2 days later, the NASA Juno probe made a very close flyby over that area, took this image, and that's the spot there that Clyde had detected with his telescope. A press release was issued by NASA, and in that press release they referred to this then as Clyde Spot, and it has ever since been known as Clyde Spot. It's still visible today, though it's no longer this form. It's now very, very contorted, sort of like these cloud bands that you can see here. So that's the type of work that Clyde does together with the NASA Juno team. My own observatory is this one. So this is my backyard, a 3 by 7 meter observatory. It houses 12-inch and a 12-inch Smith Cassegrain, 16-inch Dobsonian, and I use those telescopes for comet observation and for variable star observation. But most of my work nowadays is done on meteors. So I am the South African station for the CAMS, which is the cameras for all sky meteor surveillance. It's work that I do in conjunction with NASA Ames and with the SETI Institute. So I have a bank of 8 cameras. You can see them here in this box, which was just before I commissioned them, so the protective glass has not been fitted yet. But you can see the 8 cameras inside there. So I have 8 cameras at my site, and then around about 75 kilometers away, I have another 8 cameras at the Hartbeespoort Radio Astronomy Observatory. And together with Philip May, we monitor the skies each night, and we look for new meteor showers in the southern hemisphere. So that's typically the output that we get from this work. These are maps of the sky. Every dot that you see there is a meteor which has been logged, its orbit determined, and its radiant has been determined. So you can see here, for example, this is the output for August the 12th. You can see here, these are the Perseids. And just by the way, all of the colored dots here then are meteors. They're shower meteors. Most of the white dots you see here are sporadic meteors, and then the black dots are stars. So these are Perseids. Over here we have North Delta Aquariids, then we have Omicron Aquariids, and then in the southern hemisphere on that same night we have Eta Eridanids. So you're quite lucky in the northern hemisphere. You have quite a few good showers. So apart from the Perseids, you know the Orionids, you have the Geminids, of course when they're active, the Leonids. Unfortunately, we don't have that plethora of nice meteor showers in the southern hemisphere. The best we get to do is the Eta Aquariids. It's the most active southern shower, and it's only just a southern shower. It's pretty much on the celestial equator. So, so we spend our time looking for new meteor showers in the southern hemisphere, even if they're minor ones. We had a success recently with the detection of a new shower, which is now called the Arids. And the Arids are the remnants or the debris which has been left behind by Comet Finlay. Now, I mentioned William Finlay in one of my earlier slides. He was the assistant to David Gill. And Finlay discovered a comet in 1886. It's a periodic comet. It goes around the sun once every 6.5 years. Its orbit comes into quite close conjunction with the Earth. And it's very surprising that we've never seen a meteor shower from that. It was predicted, but there's never been a meteor shower visible from Comet Finlay. Until last year, we then, for the first time, detected meteors from that comet. You can see there are 2 outbursts. This is the 1995 ejector from the comet, and this is then dust particles left behind when the comet came around in 1914, 1915. So these are the Arids. They come from the southern constellation of Ara, the Alta, which is here, and here you have the southern, you have Scorpius and the sting of Scorpius. Okay, so I hope that gives you a little bit of the flavor of what we do in South Africa. We have some nice skies here. We have the ecliptic plane passing overhead. We have the center of our galaxy passing overhead. That gives us some opportunities for some really decent work. We have a responsibility to carry on the legacy of the astronomers that have gone before us. And at the same time, we have a responsibility to protect the night sky. And if we don't, then our children, our children's children will not be privileged to see the objects that we're privileged to see today. So I hope that gives you some idea of what we do down here. And most of the sites that I've mentioned, you can go and have a look at. We have a website, which is the ASSA website. We have the monthly notes, which you can download. They're available for free download. The Nightfall magazine is also available as a free download. You can look at all the images that our different astrophotographers take. And then if you want to have a look at a little bit more about the ASSA top 100, which are the top 100 deep sky objects, there's a separate website for that too. So with that, I thank you very much.
Tim, thank you for an excellent talk. Could I ask you to stop sharing your screen, please? As always, left in awe by some of the images, and you're very lucky, you're very fortunate to have those dark skies, and also the ecliptic practically running over your head as well.
Yes.
Yeah, being up in 53 degrees north, we have neither, but there you go. Ladies and gentlemen, it's question time. So if you have a question, can you put a digital hand up? Otherwise, can you wave at me furiously? And we will get something going. So, Mick Nichols, Mick, put your dog down, turn on your microphone.
Yeah, can you hear me?
Yes, I can.
Yep.
Yeah, I was just wondering if you had many solar observers at all.
No, we did in the past, but nowadays there aren't many people doing solar observing. So we had people who counted sunspots. We had one observer who had an SED, sudden enhancement. I can't remember exactly what that stands for, measuring solar radiation. But solar observing seems to be a pastime that that nobody's interested in doing that down here anymore.
I must admit that does surprise me, because from Africa, I'd have thought you'd got some really good skies for it.
Yeah.
Maybe it's because they've got better skies for night side, Michael. It's simple as that. Why waste your time looking at a big bright ball? It's you might have guessed that Michael's a very keen solar observer. He takes some absolutely wonderful images in all wavebands.
Can I maybe just ask Mick a question then? Do you feel that there is really a need for amateur observing the sun? If you have, you know, I mean, you have the SOHO satellite. You know, if you want to do sunspot counts and radiation counts, you know, you have satellites doing that today. It's sort of like, you know, comet discovery. Amateurs don't do comet discovery anymore because there are so many telescopes looking at, professional telescopes looking at these objects, that there's just no place for amateurs. Are you not finding that amateurs are starting to be pushed out by these plethora of professional telescopes and satellites which are looking at them, including the sun?
I'm actually glad you've asked me that, because even the professionals with all their satellites and everything looking at the sun, they still do miss things. And in 2012, I actually assisted NOAA with the detection of a C-class flare, what they missed. Okay. So I think there's always a space for amateurs in any field of astronomy to be able to assist the professionals.
Thanks very much for that comment. It's something that I will take back to our committee here and just ask, why are not more people getting involved with solar observing?
Can I jump in as well, Paul?
Yeah, Andy Davey. Andy Davy's in Spain, but he used to live in this area. And like Mike, he is a keen solar observer.
Yeah, well, you talked about the SDO and so on, what have you. But a lot of the instrumentation on the SDO, it drowns out when flares occur. So some of our amateur images will be able to get more detail of the flare event itself in hydrogen alpha.
Okay.
Okay. Thank you for that, Andrew. Chris Stewart.
Yes, we used to have a solar section in the society that was actually quite active, and the two prominent people from that were Pam Cook and Jim Knight, but it fell dormant when we didn't have a person to run the section any further. But I think most people are more interested in the night sky. Still, from our telescope making class, one guy, Percy Jacobs in Victoria, built his own hydrogen alpha solar telescope from scratch. So there is still some degree of interest, but Percy is into spectroscopy. So that's where he puts his efforts that you will see results from, but he still uses his solar telescope.
Right.
Thanks,
Thank you very much for that, Chris.
Can I just come in again, Paul?
Yes, you certainly can.
Yeah, just another one, Tim. What we found particularly, well, it's over 10 years ago since I was at UK, but particularly on public outreaches, on nice afternoons at weekends, solar telescopes go down very well with the general public and can help draw your new members in. Even something as small as a personal solar telescope or a PST Coronado, which back then were about 500 quid or slightly less. But, got great interest, and we managed to make quite a bit of money out of that for observatory, can you remember, Paul? in the donations tin.
Oh, well, that's something else altogether. Jess, I'm going to just park you for a moment. I'm going to go back to Chris Stewart because I think it's in this general vein.
Yeah, can I ask Tim to share the screen that he had with some homemade telescopes, because amongst them is a solar telescope that I'd like to comment on.
Can I do that, Paul?
You
Is that
certainly
okay?
can.
Can you see it now?
Yeah. The 1 second from left at the top row, right, is a white light solar telescope that we built, 3 of us, in one weekend, which was then donated to a youth education organization in Johannesburg. And this gets frequent use with students from impoverished areas coming through the Science Center. And it's not so obvious from this picture, but what's happening is there's a sort of lid on the top that just flaps out of the way, and then that acts as a sunscreen for the observer to put his eye by the Newtonian focus. And then you can see on the part facing us near the top of the telescope is an optical window, which is actually a platen from an old photocopier scanner, thin optically good piece of glass, which has been illuminized on the inside. So the vast majority of the sunlight coming in gets rejected out towards the ground through that aperture you can see there. And of the small amount that does get through, gets down to the primary mirror, which is unsilvered. So only about 4% of that amount of light is reflected. And it comes back to that optical window, which again acts as a secondary mirror to bring it out to the Newtonian focus, where there's additional filtration at the eyepiece. And I can't say how many hundreds of kids have looked through this thing, but many hundreds. And on an active day when they're good sunspots, then it always impresses them.
Thank you for that, Chris. Okay, we'll go to Jez Robinson, who's been waiting patiently. Jez?
Oh, I do try. Yeah, I was interested in your meteor camera matrix that you got. It was the directions of the lenses and the cameras that you got. Have you got a lot of overlapping video of your meteor sky, of your sky area? I mean, normally I would kind of expect the lenses to be pointing outwards rather than pointing inwards together. That was all that intrigued me, I suppose.
Yeah, well, I mean, you can also point them outwards, but I can't remember exactly what the field of view of they are. They're about 25 degrees wide fields, and the cameras are arranged so that the rectangles of those fields, they just overlap with each other.
Right. Okay. I wondered if that, so you could gauge the direction better, or as it was coming across the sky.
No, so we've got there are two setups. So I've got my setup of 8 cameras. They're arranged then in 8 rectangles which are stacked.
Right.
So 4 by 2. And they point to a certain position up in the sky, an altitude of around about 75 degrees. And then I have 8 cameras which are about 75 kilometers away on exactly the same mounts. They're mounted exactly the same way. And they are pointing in my direction so that the fields of view of those 8 cameras overlap at an altitude of 95 kilometers above the Earth's surface.
Right.
And that is the area where most of the meteors burn up. So most meteors start to burn up or deflagrate at around about 100 to 120 kilometers high. They reach their peak brightness at around about 95 kilometers. By the time they get down to 80, they pretty much are burnt out. So we arrange these cameras so that the fields of view of the 2 sites overlap at 95 kilometers above the Earth's surface. And so both, all of the information then gets fed into a computer. The cameras have got frame grabbers on them. So if there's a meteor goes through the field of view, the frame grabber grabs that, and then the software looks for frames where the same meteor has been captured from both sites. It triangulates, does all the astrometry against the stars which are visible in the field at the time, and from that we determine the orbit of the meteor.
Is that a custom piece of software, or is it open source software, or something you've written? Or
so the software is developed specifically for the CAMS group. There is another group, Global Meteor, I think they call themselves Global Meteor Survey or something like that. They have some open source software that they use on their cameras, and a lot of people are looking at that now. So, but the work that we do with CAMS, that's all purpose software made specifically for CAMS.
Yeah, thank you.
Okay,
Great,
Jez.
great talk, by the way. Thank you. Very inspirational. Thanks.
Jez, Tony Morris, please.
Hi, Tim. I'm just wondering whether you have seasonal observing programs. So here in the UK, in midsummer, it might only get dark for a couple of hours. So as Andy suggested, you know, the solar observing becomes more interesting in the summer months, but in the winter months when we've got, say, 10-hour, 12-hour dark nights, do you have something similar for your observing?
Well, to some degree, you know, we're a lot closer to the equator. So, you know, even in our summertime, by 8 o'clock in the evening, it's dark. It gets light again at around about 3:30 in the morning. So even during our high summer, we have around about 7.5 hours of really dark skies that we can observe. Unfortunately, where we are in Johannesburg, that's also our rain season. So then as we go into winter where we are, it's our dry season. We have no clouds at all for several months. And then it gets dark at around about 6 o'clock in the evening, gets light around about 5:30, 6 o'clock in the morning. So during our winter, we have around about 12 hours. So it ranges between 7.5, 8 hours in summer to 12 hours in winter. So we don't have these very short nights that you have in the UK.
Okay, Tony.
Yeah, fine, thanks.
Andy Davey wants to talk to us again. Andy, unmute yourself. I can't believe I have to say that to him. Unmute yourself, Andy.
First thing, Tim, an excellent talk. I really enjoyed it. But my question is, are you able to distinguish between meteors and any returning space debris?
Yes, yeah. So space debris, the speed of trajectory across the sky is a lot slower. So so the software will automatically it will, the cameras will pick up all sorts of things. They pick up insects, they pick up birds, they pick up aircraft, they pick up satellites, artificial satellites, and then meteors. So the software is designed that it filters most of that out. Something like a satellite, which passes quite slowly across the sky, it just takes too long. It will automatically filter that out. Same thing with space debris. Space debris will take a long time compared to a meteor to go across the field of view. So it will just automatically reject that as being improbable as a meteor.
Okay, thank you. And Tony Morris, back to you.
Hi, Tim. In 2013, I was lucky enough to go to the SALT Observatory. And the gentleman who was giving us the tour of the observatory was talking about public engagement and engagement to the South African universities in science and technology. Do you guys get involved in supporting any of that?
Yes, we do. So we have a lot of interaction with professional astronomers, and also we have ASSA sponsors students. So we have Chris, I think you'll know more about this than I do, but we have an annual scholarship which is given out every year to a student for tertiary education in astronomy. Chris, do you want to maybe just chip in?
Yes, in fact, we've got 2 bursaries that we give out to deserving causes. And I'm happy to say that the selection committee have done a good job because the students have always excelled. And we've had a number of women, in fact, in recent years who've gained those bursaries. And the one is going on to a master's at the moment. But outreach for the general public is normally a function of the centers. I have star parties and the like that the public can attend.
I would just say, Tim, it was really nice observing without being wrapped up from head to toe. So it was a really nice evening when we were out at the SALT Observatory.
Well, you were lucky because Sutherland is known to be the coldest spot in South Africa. Even during the height of our summer, they can have snow on the top there. So, and I've been up at Sutherland during winter time, and it gets pretty cold.
Right. Okay.
It does,
So
and the wind
you were lucky
as well. I nearly got blown off the mountain one night, literally.
I'm looking around for further questions. So, Mick Nichols, over to you.
Yeah, I was just wondering, the actual, how can I put it? The telescopes, what you don't make, the ones you buy off the shelf from a dealer, do you have much trouble in South Africa getting them? Because the number of people I have on Facebook contacting me from abroad saying, do you know anybody abroad that stocks this scope or stocks that scope? You know, sometimes I get like 1 or 2 a day of them. So do you have any problems getting your equipment in South Africa?
Well, we do. The problem isn't availability. The problem is finances. You know, our rand is very weak as an international currency. So it's actually quite dismal for us. So we have a very strong second-hand market. On our website, we help the people to get the telescopes to good new homes, and it's very active. And of course, we have the telescope making class, which has been running continuously for 30 years now. And we've had a couple of 100 telescopes come out of that. So, but yes, I think finances are the big problem. I mean, I've imported stuff myself, and then I've had to deal with government agencies that don't know their own rules, you know, and that's quite bad. But we have a couple of people that do import on a sort of grander scale, and telescopes are available at some shops, right? But it's better if you know what you want up front, which most people don't.
Okay, Mick.
Thanks, Chris.
All right, so I'm going to do this really, really quickly. Ladies and gentlemen, we've worked Tim hard enough this evening. So can we give Tim Cooper a big Mexper and Swinton Astronomical Society? Thank you. Thank you, Tim, for an excellent talk. Thoroughly enjoyed it.
Thank you very much.